Namaskaram. There are several type of series expansion for a function. In this session, we will discuss Taylor series of a real valued function. Yes, this is the definition. If f of x has derivatives of all orders at x naught, means f dash of x naught, f2 dash of x naught, etc. Everything exists. Then Taylor series of f of x about x naught is defined by like this. F of x can be written as f of x is equal to f of x naught plus x minus x naught by 1 factorial into f dash of x naught. F dash of x naught means first derivative at x naught. X minus x naught square by 2 factorial into f2 double dash of x naught. That means second derivative of f at x naught plus etc. And this is the compact notation of this infinite series. Sigma n equal to 0 to infinity x minus x naught raised to n by n factorial fn of x naught. And what is fn of x naught? Here fn of x naught means nth derivative of the function at x naught. Okay, for example, what is f2? F2 means second derivative of the function. Okay, that is this is our f2 of x naught means same as f double dash of x naught. Okay, the most then what is the first one? When n equal to 0, what happened? This time is x minus x naught raised to 0, that is 1. 0 factorial conventionally 1, 0 factorial is 1, and so this time is 1, and this is f0. This is f0 of x naught, right? And what is the meaning of f0? Fn means nth derivative, so f0 means no derivative. No derivative means what? It is same as f of x naught. So first term is same as f of x naught. Okay, anyway, this is the compact form of this infinite series. So Taylor series says that a function satisfies this condition, then f of x has a series expansion like this using the derivatives. Okay, then there is a natural question: for what values of x this expression is true? Or okay, or so that is answered by this next sentence. This representation is valid in the largest open interval with the center at x naught in which f of x is differentiable. That means in interval is of the form mod x minus x naught less than r. Okay, and this largest interval is called interval of convergence, and this r is called radius of convergence. Then what is the form of this interval? That means this means what? This means minus r less than x minus x naught less than r. This is the meaning of modulus of x minus x naught less than r. That means what is the range of x? If you add an x naught on both sides, so this implies x naught minus r less than x less than x naught plus r. Okay, so it is clear that this is an interval of like this. Suppose this is our x naught, then x naught minus r. Suppose this length is r, and this point is x naught minus r. And whatever the upper bound of this interval, that is x naught plus r. That means this length is same as r. Okay, so this length is called radius of convergence, and an interval like this, okay, with the center x naught, such that our function is differentiable. Such interval is called interval of convergence. The largest such interval is called interval of convergence. Okay, so always this interval of convergence is of this form. Okay, so next one is Maclaurin series. Maclaurin series is a special case of Taylor series. That is a Taylor series of f of x about 0. Okay, is called Maclaurin series. So what is the form of Maclaurin series? Instead of in Taylor series, we use the general point x naught. Okay, here instead of x naught, what is the value of x naught in Maclaurin series? X naught is 0. So only difference is we replacing x naught by 0, that's all. So what about the series expansion? F of x is equal to f of 0 plus our second time is actually x minus x naught by 1 factorial into f dash of x naught. So in the case of Maclaurin series, this x naught is 0. So this become x by 1 factorial into f dash of 0. Similarly, the third term is x square by 2 factorial into f double dash of 0 plus etc. And this is the compact form of this infinite series. Sigma n equal to 0 to infinity x raised to n by n factorial fn of 0. So only difference is in the case of Maclaurin series, this is same as Taylor series. Only thing is x naught is 0. That's all. Okay. Okay, consider a problem. When the Maclaurin series of f of x equal to 1 by 1 minus x, also find the interval of convergence and radius of convergence of this problem. Hence, evaluate the Maclaurin series of this function f of x, or this is actually f of x. F of x is equal to 1 by 1 plus x. Okay. Okay, we know that the Maclaurin series of f of x is equal to, given by the formula, f of 0 plus x by 1 factorial into f dash of x naught, etc. So we have to find all these derivatives. Okay, so f of x is given, that is 1 by 1 minus x. So what is f of 0? When x equal to 0, this become 1. So f of 0 is 1. Next we have to find f dash of x. What is the derivative of 1 minus x? Yes, f dash of x is equal to minus 1 by 1 minus x whole square into minus 1. So what about f1 of 0? When x equal to 0, this term become, this term is minus 1. When x equal to 0, this is minus 1 by 1 square, that is minus 1 into 1 more minus 1. Okay, so next we have to find f2 of x, second derivative of x. So differentiate this one. Okay, so derivative of this expression is minus 2 by 1 minus x whole cube. Already 1 minus 1 is there, into minus 1. So already 1 minus 1 is there, so this become minus 1 square. Okay, so what is f2 of 0? When x equal to 0, this term become 1. So this is minus 1 into minus 2 into minus 1 square. Right. Okay, continuing in this way, my question, what is fn of 0? You can generalize it. Yes, when n equal to 2, this is minus 1 into minus 1 square. When n equal to 3, what happened? This is minus 1 into minus 2 into minus 3 into minus 1 raised to 3. So what is fn of 0? Minus 1 into minus 2 into etc. into minus n into minus 1 raised to n. Right. And you can simplify. There are n minus 1s. So minus 1 raised to n into 1 into 2 into etc. n, that is n factorial into minus 1 raised to n. So what is minus 1 raised to n into minus 1 raised to n? Minus 1 raised to 2n into n factorial. Since 2n is even, what about minus 1 raised to 2n? That is 1. So this become n factorial. So fn raised to 0, fn of 0 is n factorial. So this is the nth derivative. Okay, when n equal to 0, that is no derivative, that is f of 0. That is 0 factorial, that is 1. Okay, anyway, we are ready to write our general Maclaurin series using these derivatives. Okay, so our f of x is 1 by 1 minus x. That is equal to f of 0. What is f of 0? When n equal to 0, f of 0 is given by 0 factorial, that is 1. Or from this equation, it is 1. So 1 plus x by 1 factorial into f dash of 0. What is f dash of 0? When n equal to 1, this become 1 factorial, right? So 1 factorial plus x square by 2 factorial. f2 of 0 is 2 factorial, right? 2 factorial plus etc. So this is equal to 1 plus x square plus etc. plus x cube etc. So we can expand 1 by 1 minus x like this. So this is the series expand. This is a Maclaurin series expansion of 1 by 1 minus x. 1 plus x square plus etc. Or we can use this compact form. In compact form, what happened? This is n equal to 0 to infinity x raised to n by n factorial into fn of 0. In general, we know for this problem, we know what is fn of 0. That is n factorial. That is equal to sigma n equal to 0 to infinity. Okay. Anyway, both are same. Okay. Then next you have to find the interval of convergence. Interval of convergence means for what values of x this expression is valid, this equation is valid. Okay. So we know that interval of convergence is always about 0 for a Maclaurin series. So we have to find our R, right? Yes, we have to find the largest R such that our function is differentiable. Our function is 1 by 1 minus x, and it is clear that this function is not differentiable at x equal to 1, right? It is not differentiable at x equal to 1. So my question, what is the largest interval such that mod x less than r? What is the largest interval of the form mod x less than r such that this function is differentiable? Yes, it is clear that r equal to 1. Okay, so the interval of convergence is mod x is less than 1. Clear? If if it if r is greater than 1, what happen? That interval includes this one. That means function is not differentiable in that interval. So we have to find largest interval of this form such that our function is differentiable. This form means minus r less than x less than r. Okay, so this is possible. The maximum such r is 1. So that's why this is the interval of convergence. That means in this interval, in this interval, this equation is valid. This expression is valid. Okay, and okay, what is the radius of convergence? That maximum r is called radius of convergence. So in this problem, the radius of convergence r equal to 1. Okay, the region of validity means suppose you choose a point outside this interval. For example, you choose a point 2. 2 is outside this interval of convergence. Then this is not valid. For example, you can easily verify. For suppose you choose x equal to 2. Then what about the LHS? LHS is 1 by 1 minus 2. That is equal to minus 1. Right? 1 by minus 1, that is minus 1. What about the right hand side? Right hand side is 1 plus 2 plus 2 square plus etc. Anyway, it's a positive quantity and tending to infinity. Okay, LHS is minus 1, right side is positive and tending to infinity. It is clear they are not equal. So this expression is valid only in this interval, only in the interval of convergence. That means if you choose a point from this interval, for example, you choose 0.5, then what is the left side value? That is 1 by 1 minus 0.5. That is 1 by zero point 0.5. That is 2. Right? You substitute 0.5 right hand side. That become 1 plus zero point 0.5 plus zero point 0.5 square, etc. This also gives the same sum too. That's the idea. Okay. So this equation is valid only in the interval of convergence. That is very important. So that's why this interval of convergence is also important. A series expansion is valid in the interval of convergence. Okay. Yes. So this is the series expansion of 1 by 1 minus x. This is a compact form sigma n equals 0 to infinity x raised to n and valid in this interval. This is our interval of convergence and radius of convergence is 1. Okay. So next we have to find Maclaurin series of f of x is equal to 1 by 1 plus x. Either you can find the Maclaurin series using the same method. That means you find the derivatives and substitute in Maclaurin series formula. Actually here we have to find, we can easily find the Maclaurin series of this function using this non-Maclaurin series. Okay, how to find the Maclaurin series? 1 by 1 plus x. We know that the Maclaurin series contains only the terms x and its powers. Okay, so we can write this as 1 by 1 minus x, right? So now this is of this form, 1 by 1 minus x. Okay, and what is the series expansion of 1 by 1 minus x? 1 plus x square, etc. So this become 1 plus minus x plus minus x square plus minus x whole cube plus etc. And what is the region of validity, or what is the interval of convergence? In this case, it is mod x less than 1. So here instead of x, minus x. So this become modulus of minus x less than 1. Okay. Then you can simplify this expression. This is 1 minus x and this is minus x square. That is same as x square. And this is minus of x cube plus minus etc. And what about modulus of minus x? The same as mod x, right? Less than 1. So this is the series expansion. This is the Maclaurin series expansion of 1 by 1 plus x, right? 1 minus x plus x square minus x cube plus etc. Alternative plus or minus. And this is valid in the same interval mod x less than 1. Okay. Okay. Okay, next problem. Find the Tailor series of f of x is equal to 1 by x about x equal to 1. Okay. Also find the interval of convergence and radius of convergence. So either you can use the direct formula of Tailor series. What is the formula of Tailor series? Okay, this is the formula of Tailor series about x naught. Here instead of x naught it is 1. So in our formula that is like this, f of 1 plus x minus 1 into f dash of 1 and this is x minus 1 square by like this, and f2 of f2 at f2 of 1 plus etc. So the interesting thing is, if a Taylor series about x naught contains terms of the form x minus x naught and its powers. So in this case, our Taylor series contains terms x minus 1 and its powers. Clear? So we are going to use a special technique. We are going to expand this 1 by x about 1 using non-Maclaurin series. Okay, using the fact that the Taylor series of this function contains x minus 1 and its powers. So consider the function f of x, that is 1 by x. So I'm going to convert this x in terms of x minus 1. That means you subtract a 1, so plus 1, right? So this is equal to 1 by, you can rearrange this like this, 1 plus x minus 1. Now this is of the form 1 by 1 plus x, right? 1 by 1 plus x. And what is the series expansion of 1 by 1 plus x? That is 1 minus x plus x square minus x cube plus etc. and valid in this interval. Okay, so this is equal to, here only difference is instead of x it is x minus 1. What happened? 1 minus x minus 1 plus x minus 1 whole square minus minus 1 whole cube plus minus etc. And what is the region of validity or interval of convergence? That is, here it is mod x less than 1. So here instead of x, x minus 1. So mod x minus 1 less than 1. So this is the interval of convergence. Okay, it is clear that this interval with the center 1. And this is the Maclaurin series of 1 by x about x equal to 1. Clear? You can also find this same Taylor series using this direct formula. That is more computationally expensive. You have to find all the derivatives and derivative at the 1, then substitute in this formula. That gives the same answer. Okay, but this is very easy. So here we use a non-Maclaurin series for evaluating the Taylor series. Okay, this is a very good technique for evaluating some Taylor series. So this series, that is, this is equal to actually 1 by x. So this series expansion is valid in this interval. Okay. So what is the radius of convergence? Yes, here the radius is 1. Okay, next problem. Find the Maclaurin series of sin x. Also find the region of validity and radius of convergence. So region of validity means our interval of convergence. Okay. So we know the Maclaurin series. So yes, this is our Maclaurin series. So we have to find f of 0, f dash of 0, etc. So given that f of x equal to sin x, so what about f of 0? That is sin 0, we know that it is 0. Next one, its derivative. That is equal to derivative of sin x, that is cos x. So f dash of 0 equal to cos 0, and we know that cos 0 is 1. Next we have to find second derivative. What's the derivative of cos x? That is minus sin x. So you can substitute x equal to 0. Yes, so f2 of 0 equal to minus sin 0, that is 0. Next we differentiate this f2, that is f3, that is minus cos x. So what is f3 of 0? That is equal to minus cos 0, that is equal to minus 1. Then what about f4 of x? Cos derivative of cos x is minus sin x. One more minus is there. So this is same as sin x. That is same as our first one, right? So what about f4 of 0? That is same as sin 0. That is 0. Then what about f5? f5 of x? That is same as our second one. Clear? This is same as this one. That is cos x. So f5 of 0 equal to the second one. That is 1. So now the pattern is there. So after this first 4, then it's repeating. Again 0, 1, 0, minus 1 like that. Okay, now we are ready to write our series expansion of sin x. So what is the series expansion of sin x? F of 0, f of 0 is 0, then plus x by 1 factorial, x by 1 factorial into 1. This is our f1 of 0 plus x square by 2 factorial into f2, that is again 0, plus x raised to 3 by 3 factorial into minus 1. Okay, then it's repeating like this, 0 1 0 minus 1, like that. Okay, so next term is 0. Clear? Then next, then whatever the next term, this is corresponding to x raised to 4. So next one is x raised to 5 by 5 factorial into 1, right? Then so all the even terms are 0. So whatever the simplify, if you simplify this series expansion, sin x become what? This is x minus x cube by 3 factorial, right? Then next term is x raised to 5 by 5 factorial minus plus etc. Okay, next we have to find the region of validity or interval of convergence. We know that interval of convergence of Maclaurin series always of the form mod x less than r. So we have to find the largest such r such that this function is differentiable. What about sin x? And we know that sin x is differentiable everywhere. Okay, so what is the largest such r? We know that sin x is differentiable in under real numbers. So what is the maximum of r? What is the maximum of r? That is equal to infinity. So the interval of convergence of this problem is mod x less than infinity. That means entire real numbers. Okay, so in this case, its radius of convergence is also infinity. This is our radius of convergence. Okay, so this series expansion of sin x is valid in the all real numbers. Yes, so this is the series expansion of sin x. This is the compact form of this infinite series. Sigma n equal to 0 to infinity minus 1 raised to n into x raised to 2n plus 1. X raised to 2n plus 1 means this power is always odd, right? When n equal to 0, this is 1, the first term. When n equal to 1, this is 3. Clear? And x raised to 2n plus 1 by 2n plus 1 factorial. And this series is valid for all the real numbers. That means its interval of convergence is mod x less than infinity. That's why its radius of convergence is infinity. Clear? Okay, this is your homework. We have to find the Maclaurin series of cos x. Also, we have to find the region of validity and radius of convergence. Okay, thank you.